Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So here we are required to evaluate the orthographic projections of a line AB which happens to be inclined to the horizontal plane and parallel to the vertical plane. So let us go through the problem statement. So end A point of a line AB, it is lying in the horizontal plane. That is, the front view will be obtained onto the XY reference line. And end A is lying 40 millimeter from the vertical plane. That is 40 millimeter in front of the vertical plane. Whereas end B, it is lying 60 millimeter from the horizontal plane and 40 millimeter from the vertical plane. Further, it is mentioned that the distance between the end projectors as measured parallel to the XY reference line, it happens to be 70 millimeter. So we are required to draw the front view, the top view and the right hand side view orthographic projections of this particular line AB, assuming the line to be located in the first quadrant. So let us proceed with the construction of the orthographic projections of this particular line. So here we have got the XY reference line, X1, Y1 reference line and the transfer line which has been drawn over here at an angle of 45 degree, right? So this transfer line has been drawn in order to be able to convert the distances of the 2 points A and B in the top view from the vertical plane into the profile plane distances over here. Now here we know that the end A of the line, it is lying in the horizontal plane. So the point A dash will be located onto the XY reference line. So the front view of the point A or the end A of the line, it is lying on the horizontal plane or on the XY reference line, and we are assuming that this line, it is lying in the first quadrant. So the distance 40 millimeter of the end A from the vertical plane will be assumed as 40 millimeter in front of the vertical plane, so that this point lies in the quadrant number 1. So here 40 millimeter in front of the vertical plane will be drawn below the XY reference line. So the point A, that is the top view projection corresponding to the point A has been obtained. The front view projection A dash corresponding to the point A has been obtained. Now we know that the distance between the end projectors of the line AB measured parallel to XY line, it happens to be 70 millimeter. So now from the end projector of the point A, we are going to mark a distance of 70 millimeter, and at a distance of 70 millimeter we are going to draw the projector line corresponding to the end projector of the point B of the line AB over here. So since point B happens to lie in quadrant 1, so the front view of this particular projection of point B, that is B dash, will be lying above the XY line, and the top view projection, that is point B corresponding to the point B of the line, will be lying below the XY reference line. So we know the coordinate locations of the point B with respect to the two reference planes. So end B, it is lying 60 millimeter from the horizontal plane, that is 60 millimeter above the horizontal plane we have to take this point. So from this XY reference line, we are going to mark a distance of 60 millimeter in this direction, and we are going to mark this point B dash, that is the front view projection corresponding to the point B in the vertical plane over here. Now having obtained A dash and B dash, now we can join projections of A dash, B dash to provide us with the front view projection of this particular line AB in the front view. Now we also know that end B, it is lying at a distance of 40 millimeter from the vertical plane. Now since the line happens to lie in the first quadrant, so this distance of 40 millimeter from the vertical plane we have to take as plus 40. So plus 40 means 40 millimeter in front of the vertical plane. So we observe that the distance of the point A from the vertical plane is also 40. The distance of the point B or the end B of the line with respect to the vertical plane, it is also 40 millimeter in front of the vertical plane. So with this we have been able to obtain points A and B at a distance of 40 millimeter below the XY reference line. So therefore we have been able to obtain AB projection line, that is the top view projection line corresponding to the line AB parallel to the vertical plane. And since this top view projector AB of the line AB parallel to the vertical plane, therefore the front view A dash B dash happens to be the true length of the line. Since here we have got the apparent length projection of the line, it is located parallel to the vertical plane. So the front view describes or reveals the true length projections of the line onto the vertical plane. So having obtained the front view, having obtained the top view projections, now we will proceed with the evaluation of the side view projections of this particular line, and we are required to draw right hand side view projection of this particular line over here. So since we are required to draw the right hand side view projections, so in the first angle projection, the right hand side view projections, they will be obtained on the left hand side of the front view, right? So at whatever height point A dash is located in the front view, at the same height we are going to obtain the location of the point A double dash in the profile view. Now since point A dash is located into the horizontal plane, so the location of the point A double dash will be also located onto the XY reference line. So we assume that we have drawn a horizontal construction line through A dash in such a way that we are going to mark the distance of the point A from the plan into the profile plane, and we will be able to obtain the location of the point A double dash on the same horizontal construction line drawn through the point A dash. Now here we see distance of the point A from the vertical plane is, it is plus 40, that is 40 millimeter in front of the vertical plane. So from this point A, now we can check that this distance of 40 millimeter in front of the vertical plane, we have to transfer it from the top view into the profile view projection. That is, this distance should be 40 millimeter, right? So how this can be obtained? We have to draw a horizontal projector line through the point A in the plan and continue to extend this projector line till this projector line drawn through the point A, it intersects with this transfer line at this position. So wherever we get this point of intersection, now we have obtained a point onto the transfer line corresponding to this plan projection line. Now from here we are going to draw a vertical projector line and extend this projector line till this vertical projector which is being drawn upwards. This will be intersecting with the horizontal construction line which has been drawn through the point A dash over here. So this point of intersection will provide us with the location of point A double dash into the profile plane projection. So here we can check the location of point A double dash into the profile plane. It is lying onto the horizontal plane and it is lying at a distance of 40 millimeter in front of the vertical plane over here. So this way A double dash point has been located. That is, this distance of point A in the top view from the vertical plane, it has been transferred into the profile plane as distance from the vertical plane over here, right? So this way this distance has been transferred over here and we have been able to obtain the point A double dash. Similarly, B double dash point we need to evaluate. So here we can see at whatever height point B dash is located into the orthographic front view projections, so at the same height, that is 60 millimeter height, if we draw a horizontal construction line, so onto this horizontal construction line we are going to obtain the location of the point B double dash into the profile plane projections over here. So onto this horizontal construction line, we are going to obtain the location of the point B double dash. Now how that can be done? Height we have already drawn corresponding to the point B double dash. So B double dash will be lying 60 millimeter above the horizontal plane. Right? Now we know that the point B, it is also lying at a distance of 40 millimeter in front of the vertical plane. So this distance of plus 40, that is 40 millimeter in front of the vertical plane, it will be translated from the top view into the side view. So please check, from the point B, we are going to draw a horizontal projector line and extend it till it intersects with the transfer line over here, which is drawn at the angle of 45. So over here at the same point, we are going to obtain this particular intersection. That is, this distance is 40 millimeter. That is, this distance of 40 millimeter in front of the vertical plane from the top view has been converted to 40 millimeter in the front of the vertical plane into the profile view projection. So from this point, once again, we are going to draw a vertical projector and keep on extending this projector till it intersects with the horizontal construction line, which was drawn earlier from the point B dash, which was defining the height of the location of point B double dash. So point B double dash will be located by virtue of intersection of these two projector lines over here. So A double dash has been obtained, B double dash has been obtained. Now if we check the coordinate location of B double dash, it is lying at a height of 60 millimeter above the horizontal plane and 40 millimeter in front of the vertical plane. So this way we have been able to obtain both of these points, A double dash and B double dash. So having obtained these 2 points, A double dash and B double dash, now we can join these 2 points and the right hand side view projections, that is the apparent length projections of this particular line, have been obtained into the profile plane. So this way we have discussed about the evaluation of the front view projections, the top view projections and the right hand side view orthographic projections of a line AB, which is located in the first quadrant. So this is all for today. So I hope that through this discussion you would have understood about the procedure to evaluate the orthographic projections of the line AB, which happens to lie in quadrant number 1. So we'll be continuing with the further discussion regarding few more illustrative cases of the projections of the line in the coming lecture. So thank you very much. Thanks a lot.